In this video, we're going to take a look at linear functions, and we're going to find how to find the intersection between two lines, and then we're going to learn how to create revenue, cost, and profit functions. So in this first example, we have find the intersection point of y is equal to 3x minus 3 and y is equal to negative 2x plus 7. And for this problem, we're going to set the two equal to each other. So we're going to have 3x minus 3 is equal to negative 2x plus 7. And now I'm going to add 2x to both sides, and I'm going to add 3 to both sides so I can combine like terms. So on the left here I have 3x plus 2x gives me 5x. And on the right I have positive 3 plus 7 gives me 10. So x is equal to 2. And now we need to find the intersection point, and we just found the x value. So in order to find the y value, you can plug 2 into either of the functions. So I'm going to use the first function. So y is equal to 3 times 2 minus 3. So we have 6 minus 3, which is equal to 3. So y is 3. So our intersection point is 2, 3. In my next example, I have a manufacturer has a monthly fixed cost of $25,000 and a production cost of $6 for each unit produced. The product sells for $10 per unit. And we want to find the cost function, the revenue function, the profit function, and then we want to compute profit or loss at a couple of production levels. So starting in part A, we want to find the cost function. And remember, our cost function is going to be our variable cost times x, the quantity we produce, plus our fixed cost. So we have our variable cost, or our production cost per unit, is $6 times x, plus our fixed cost, which is $25,000. So this is cost with respect to x. For part B, we want to find the revenue function. So for revenue, we have price times quantity. And in our case, it sells for $10 per unit, so our revenue is 10x. And now our profit function is going to be revenue minus cost. So R of x minus C of x. So here we're going to have 10x minus 6x plus 25,000. And when we simplify this, we have 10x minus 6x gives us 4x. And then we distribute the negative, so we get negative 25,000. And this is our profit function. And now in part D, we want to analyze the profit at production levels of 5,000 and the production level at 8,000. So we're going to have 4 times 5,000 minus 25,000, which is 20,000 minus 25,000, or negative 5,000. Remember, this is dollars. So if they're making 5,000 units, they're losing $5,000. At 8,000, we have 4 times 8,000 minus 25,000, which is 32,000 minus 25,000, which gives us 7,000. So at a production level of 8,000, we have the company is making $7,000. And in my last example, I want to look at the break-even point for a company. So if we want to find the level of production that will cause the company to break even, we need to set revenue and cost equal to each other. So we have revenue is equal to 8x and cost is equal to 3x plus 500. We're going to set 8x equal to 3x plus 500. Subtract 3x from both sides. divide by 5, and we get 100. So at the production level of 100 units, this company will break even. And that's our video on linear functions.